Welcome, fellow travelers on this spaceship we call Earth. Today, our destination is Callisto, a world of ice and shadow orbiting Jupiter, and a silent keeper of ancient history. Imagine a moon so large that, if it were a planet, it would be the third largest in our solar system, bigger than Mercury. Callisto is Jupiter's second largest moon, measuring about 4,120 kilometers across, making it the third largest moon in the solar system. It orbits Jupiter at a distance of 1.88 million kilometers, taking about 17 Earth days to complete one orbit. Callisto's name comes from Greek mythology, a nymph transformed by Zeus, echoing the moon's own cosmic evolution. It's one of the four Galilean moons, first observed through a telescope in the early 17th century. These moons, Io, Europa, Ganymede, and Callisto, revolutionized our understanding of the cosmos. Their discovery proved not everything in the heavens revolved around Earth, challenging centuries of belief. Callisto, the outermost of the four, became a new world to explore and a new chapter in our cosmic story. Let's journey to this ancient frozen world and uncover its secrets. Picture the year 1610. Galileo Galilei points his telescope at Jupiter and sees three bright points of light. At first he thinks they're stars, but soon realizes they move with Jupiter, they're moons. This discovery shakes the foundations of science, challenging the idea that everything orbits Earth. Within a week, Galileo spots a fourth moon, Callisto. These four Galilean moons become the first celestial objects seen through a telescope, invisible to the naked eye. Galileo's observations, published in Starry Messenger, ignite debate and a new era of astronomy. Callisto's slow orbit and distance from Jupiter make it easy to track, playing a key role in Galileo's findings. Each night, the moon's positions change, a cosmic ballet choreographed by gravity. This simple act of observation forever alters humanity's view of the universe. Callisto is more than a ball of ice and rock. It's a monument to a pivotal moment in human history. It marks the dawn of our understanding of the vast, dynamic solar system. And it all began with a glance through a telescope. When we look at Callisto, we're peering back in time. Its surface is among the oldest and most cratered in the solar system, a frozen record of 4 billion years of impacts. Unlike Europa or Io, Callisto shows no signs of geological activity. No volcanoes, no mountains, no tectonic rifts. Its crust, a thick shell of water ice mixed with rock, preserves craters for eons. Weaker tidal forces from Jupiter mean little internal heat, so the surface remains unchanged. The result? A landscape saturated with overlapping craters, where new impacts strike atop ancient ones. Space weathering darkens the surface, leaving bright, fresh craters as stark contrasts. Enormous multi-ring basins, like ripples frozen in ice, are scars from colossal impacts. Callisto's surface is a static museum, preserving the violent history of the early solar system. Beneath Callisto's battered crust may lie one of the solar system's greatest secrets, a hidden ocean. Evidence from NASA's Galileo mission suggests a vast, salty ocean could exist beneath the icy shell. Galileo detected a weak fluctuating magnetic field around Callisto, likely caused by a conductive layer, salt water. This ocean could be up to 100 kilometers thick, insulated by ice and kept liquid by pressure and anti-freeze-like salts. Even without strong tidal heating, residual heat and pressure may keep water from freezing solid. A subsurface ocean would make Callisto more than a frozen relic. It could be a dynamic world with potential for life. Shielded from radiation, this ocean could provide a stable environment for billions of years. If it contains the right chemicals, it might even harbor life. Proving the ocean's existence is a top goal for future missions, like the European Space Agency's JUICE spacecraft. Callisto's hidden depths may hold answers to some of our biggest questions about life beyond Earth. Callisto's surface is a gallery of cosmic collisions, dominated by massive impact craters. Among thousands, a few stand out. Heimdall, a 210-kilometer-wide basin, Adlinda, spanning 1,000 kilometers, and Loften, a bright, younger crater superimposed on Adlinda. These overlapping features help scientists piece together the moon's bombardment history. Asgard, a spectacular multi-ring basin, stretches 1,600 kilometers and is a ghostly remnant of a cataclysmic event. But the king of all is Valhalla, a planetary-scale scar with a bright central region and rings extending nearly 3,800 kilometers. Valhalla's formation likely involved an impactor punching through the icy crust, possibly over a subsurface ocean. These immense structures are more than scars. They're records of the solar system's violent youth. By studying them, we learn about Callisto's crust, its history, and the forces that shaped it. Each crater is a chapter in the story of our solar system's chaotic beginnings. Callisto's craters are windows into the past, revealing the power and scale of cosmic impacts. Let's take a closer look at Valhalla, Callisto's most magnificent feature. Valhalla isn't just a crater, it's a testament to the unimaginable energies of the early solar system. At its heart lies a bright, smooth plain, surrounded by rugged rings of hills and ridges. Beyond, concentric troughs ripple outward for nearly 1,800 kilometers, frozen shockwaves from the impact. Valhalla's structure hints at Callisto's interior, a brittle ice shell over a softer, possibly liquid layer. The impact likely punched through the crust, sending shockwaves through a subsurface ocean or slushy ice. Studying Valhalla helps scientists model the moon's crust and interior, revealing its ancient secrets. This colossal basin is more than a scar, it's a natural probe into Callisto's hidden depths. Valhalla is a geological cross-section, a history book written in ice and rock. It stands as a silent witness to the cataclysms that shaped our solar system. Beyond giant basins, Callisto features unusual impact chains, like the Gulsina crater chain, a straight line of at least 15 craters stretching over 600 kilometers. These chains form when a comet or asteroid is torn apart by Jupiter's gravity, its fragments striking Callisto in sequence. We witnessed this process in 1994 when comet Shoemaker-Levy 9 broke apart and slammed into Jupiter. Callisto's ancient, unchanged surface is a Rosetta Stone for planetary science. By studying its craters, we calibrate the ages of surfaces across the solar system. Callisto serves as a control group, a baseline for comparing more active worlds like Earth or Europa. In Jupiter's family, Callisto stands apart. No volcanoes, no tectonic grooves, just a quiet, preserved world. Its lack of activity makes it invaluable, a pristine record of the solar system's early days. The possibility of a hidden ocean adds intrigue, making Callisto a prime target in the search for habitable environments. Callisto is a silent giant, a keeper of secrets, reminding us that the oldest, quietest places can hold the most profound stories. As we continue to explore, Callisto invites us to look deeper, into the past, and perhaps, into the possibilities of life beyond Earth. The journey to this ancient moon is just beginning.